Assalamu alaikum wa rahmatullahi wa barakatuh. Alhamdulillah, I'm blessed with another day into the 7th of Muharram 1442 today, this morning. Right, I'm back with a lot of zest and hopefully able to share with you some important information. Now, before we go on, as usual, I have to say this. Please, I considered to upload this particular slide. Please refrain yourself from watching my channel while you are in the mosque on Friday, and especially when the khatib is citing the khutbah on Friday. Please do not watch this. And also for other colleagues with other faith, well, please skip my video when you are in your place of worship. Please do your worshiping peacefully without any interruption from my voice and my video. And also when you are having a meeting with your boss, clients, and all other people with regards to your profession, with regards to your business, please do not watch this video as well, because I don't want you to be involved in making the wrong decision because you don't concentrate and pay attention in the meeting. All right, so there's another thing. And also while driving, please do not watch this video. You may have a holder, then probably you could think about it. And also especially when someone needs you to be somewhere, especially your wife calls you to the room. Okay, go to her, forget about this video, and carry on. Now I am going to bring you this morning an important part of environmental sciences management. We are still in the middle of the environmental quality Clean Air Regulations 2014 of Malaysia. We are going to look into dilution of stack emission. All right, is it allowed or is there a limitation to it? So that is what we're going to do. We're going to discuss today in this video. So let's take a look to the next slide and get going. All right, now this is a picture, two pictures. The question again is, can we dilute stack emissions and comply? Now the question is, why do we have to dilute? For a simple reason, I believe you know. As we are progressing into an era of a phenomena that you and me, we are blessed to live till this day, in which we are facing the global climate change, acute climate condition, and one of the elements that contribute, one of the factors that contribute to this global climate changes, especially in our atmosphere, is the fact that we have been emitting enormous amount of air pollutants into the air at all time. Simple as that. Industrial processes inevitably has got to transform raw materials into desired components and products, many of which uses combustion of materials. And in the material transformation chemistry, well, I believe you know thermal setting better than I do. Intermediates or broken down materials are being released as exhaust gases. Try to make it simple. The sciences is lengthy, but we make it simple for this video. So in that manner, we are burning materials either using fuel or simply using heat from electrical sources. For example, most commonly, if you and me, we are talking about ourselves as normal citizens, we do burn fuel just by driving our car, which uses fossil fuel such as diesel, petrol, benzene, etc. Those are commuters like you and me. We travel using a vehicle. It could be a car, it could be truck, it could be lorries, it could be motorcycles, it could be anything that uses fossil fuel. And that internal combustion engine generate air impurities into the air. What? Hydrocarbon residues, carbon monoxide, carbon dioxide, nitrogen oxide, sulfur oxide, etc. Okay, now that is you and me. Industries are burning in a bigger amount per space, per square feet, per square meter, because they are huge. Okay, and they burn also mostly fossil fuel. To what? Well, for example, generator set to generate electrical energy. What? Furnaces to smelt ingots, ores into various metal, to split those metal by having different melting point, by tapping those metal which melt at different melting point and get and separate those metals into the various types available in the so-called iron ore. All right, so these are all using a lot of fuel, and that combustion, not only as we know of hydrocarbon, carbon monoxide, sulfur dioxide, carbon dioxide, etc., it could have also other impurities, including organometallic compounds, volatile organic carbons, as discussed earlier in earlier videos. And these are all emitted into the air. Thereby, as years goes by, including technologies that that smelt metal without the use of fossil fuel, like arc furnace. They just use electrodes, heat up kettles, and melt ingots without combustion. But that heat is able to smelt those metals and releases also similar kinds, if not more chronic types of air impurities into the air. So that is, in short, some of the sources of air impurities that has been emitted into the air. Now listen carefully. We don't see these releases that obvious, unlike the picture I'm showing you. The picture that you have before you right now are agro-based industries, all right? And this one over here, this is an incinerator that burnt empty fruit bunches, all right, of a popular agro-based industry in this country. I'm talking about the palm oil mill, and this is this incinerator, once upon a time, was burning fibers or empty fruit punch as means of disposal. Now, not anymore. These are all generated into power. Okay, they generate steam, and from steam turn turbine and get power, which is self-generating. But then again, the combustion do happen, and look what you have here. What you have here are emissions, right? It's all getting into the air. What are they? These are more organic type of emission. Honestly, they are more biodegradable, so I don't worry about agro-based industries. But however, pollution is due to loading, and loading is measured by concentration by flow rate. You get mass over time. Remember this, mass over time. Per unit time, the mass of pollutant, if it is too high in terms of load, mass over time is too high, it then causes pollution. So pollution, air pollution, and any other pollution is not due to concentration alone and not due to flow rate alone. It is a factor of concentration and flow rate. So the mass, then we call it mass loading. All right, that causes pollution. Now back to this picture. This is another version of the organo, what do you call, emission. All right, and these are all organic, biodegradable smoke. But then, even though it's biodegradable, the environment has a limited assimilative capacity. The environment can degrade by itself, by all the components and elements in an environment. It can dissolve literally. It can break down this organic into simply water, soot, and perhaps some solids and carbon dioxide. It can be degraded, but at a limited rate and limited volume per unit time. So therefore, too much of this, even though it is a good example of biodegradable emissions of unburned organic carbon, it is still causing pollution. So what's the fuss? Why do we have a topic, can we dilute stack emissions? Well, back to the other conventional industries like metal smelters, like oil and gas refineries, petrochemical plants, metal foundries, asphalt manufacturing, asphalt, yeah, production process, what do you call it, ceramic production processes, and many others, including metal fabrication processes, most of which are either doing combustion or doing metal treatment that eventually emit air impurity into the air. So why dilute? It's a very simple reason, isn't it? Because, as I said earlier, the global climate change has forced nations to tighten up the emission standard in their respective countries, especially for member nations. And it is a common conscience for us that as we learned, as time goes by, as more data are being collected, we learn more in-depth and more wider horizon in this scope of knowledge that emission that comes from multiple sources which is located in industrializing nation where mass production of resources into products involving numerous combustion instruments, numerous smelting, including processes that transform metal from one to another by releasing impurities into the air, are actually causing certain phenomena that has changed in general our air quality and the state of which it is now in certain areas, which are influenced also by meteorological factors, are in a state of I wouldn't say, well, let us put it alarming, okay? Be serious about it. It is alarming. The global climate change is alarming. It is real. All right. The melting of glaciers is happening, and some has gone totally. All right. And the rise in global temperature is real. However, I would prefer to stick to global climate changes due to acute weather conditions. And these conditions is the environment speaking for itself. The environment is alive. The environment is a life form. When we do something, for example, by emitting foreign matter into the atmosphere, the environment speaks back, literally. Excuse me. And the environment reacts to what we did and what we are doing. We produce more impurities into the atmosphere. We can simply say we cause air pollution, but do we stop there? We might stop there, but the environment don't. The environment is dynamic. We just say air pollution, so what? What can we do? But the environment getting all these impurities, it is alive. It reacts. It reacts to our release of air impurities. How does it react? It reacts by changing its own stoichiometry, its own equation of equilibrium. An equation for the environment that many do not know, including myself, and scientists are learning about it. And many people are still learning about what is the equation for the state of environmental equilibrium, which it is supposed to be when it was created. Does anyone have the equation? So forget about the equation. Don't worry about it. But what we should do now is to ensure that as much as our knowledge permits, as much as our knowledge contribute to our capacity to think, as much as our knowledge influence our own conscience in environmental sciences, the place that we live, of course, temporarily, we must think of not only reducing emission into the environment, I'm talking about reducing loading of pollutants into the environment, but also we need to think of how can we reverse the process? Can we bring back the environment to a state of equilibrium that we would not witness further acute climate changes? It's a big question. It is easier ask than thinking about it. Coffee. I'm not taking a break, but this Arabica would help me sometime. Flavor of coffee. And coffee is manufactured with a lot of heating, frying of coffee beans using fossil fuel. I'm drinking it. So you call me environmental unfriendly? Well, this is food. We produce food that we need by emitting air impurities into the environment. There you are. All right, so this is the question again. Can we dilute? So as air impurity standards gets more stringent due to that conscience, due to the awareness that we are actually contributing in a fast rate to the atmospheric pollution, governments, scientists are suggesting that we have a higher pollution standards, higher emissions standard, so that as that happen, at least the concentration of air emission is lowered or made stagnant, despite the fact that many can't control the flow rate because the number of sources and the frequency of the emission, the period of the emission is still stagnant, if not getting more. So it's very difficult, very tough cookie to bite talking about this. All right, so it is tough. All right, so at least individually, you and me, we can try to play our part by minimizing emissions. And that, having known that and having said that, doesn't guarantee that we are able to bring back that natural environmental conditions. Okay, so many have suffered due to that strict emission standard, and they have got to invest in a lot of air pollution control equipment in order to bring down the emissions concentration. And for many companies, this is a pinch. This is taxing in terms of their operational cost. So when that happens, most businesses, the mindset of most businesses is not environmental prosperity. The mindset of most businesses is about the company's prosperity. It's about margins. It's about how to make much from so much. Or reverse, how to make so much from that much. It's about margin. It's not about environment. We can hear a lot of green technologies, green development, green policies. I'm sorry, I have to apologize to many people, but in reality, it is really superficial. Well, we admit it. But nonetheless, our effort must continue despite that, because we are living in such a system. Okay, so we have to ensure we play our part. So when there is a lot of stringent limits like this, companies will look for opportunities to still emit that amount of air impurities, because the existing control equipment which they could afford cannot cope, cannot bring down the concentration of air impurities to what the standard wanted in some cases. All right, not all cases, in some cases it is too stringent for some companies. So what they do is they find ingenious ways to release air impurities into the air at concentrations which comply. So how they do it? This is called dilution. Just by diluting. How they do it? Now let me show you. Simple. It is a simple principle of fluid dynamics. Look, this is where the impurity is coming from. Okay, it comes from here, it gets inside here. All right, maybe I change the color. The impurity comes inside here. Look, what do you see here? Constriction, isn't it? That is Venturi effect. Well, you know fluid dynamics better than I do. I'm not a mechanical engineer. I don't study fluid dynamics till the end. I am trained. I was trained by mechanical engineers who are good in fluid dynamics. So I listen to them, study with them, and know a little bit about this. Not much. You could know much, much better than I do. So what happened? When there is Venturi effect down here, constriction down here, what happens? Pressure gets less, air from outside enters. Okay, so they make a hole over here with this device. It's all customized, inducing air to come in, and air from the ambient air, from the outside air, would come in and mix with the actual air impurities inside this chamber. And this mixing brings down the concentration per unit volume. Therefore, with less concentration, some of which would go out, okay, some of the particles or impurities would go out, and the mixture will then go out into the exhaust over here, okay, and releases at concentration which comply. This is ingenious because over here you have got high volume, high flow rate, but down here in this chamber it has got some form of retention time, mixing. It is a big like a gas expansion theory, so you have got more space and more volume for mixing, and the flow rate over there is very low, and with that amount of volume they mix, and that is where you have, this is where you have, what do you call it, this is where you have the dilution. This is where you have the dilution. All right, and what comes out are actually diluted concentration. Ingenious, smart, and engineered for this, which is, well, as an engineer, it is legal. For me, if you ask me, it is a dilution. But do we bring down the concentration of air impurities in the atmosphere? The answer is no. It is still being released. Do you see this? It is still being released into the air, except that this one over here passes the emission standard, but we are still releasing impurities into the air. So if those of us who wanted to do dilution think again, we are not solving the pollution problem. We are still breathing the air, you and me. We are still susceptible to these some constituents of organometals in the air, constituents of volatile organic carbons in the air. Remember butadiene? And we are still vulnerable to carcinogenic effects to our body. Do we want that? So dilution in this manner doesn't solve environmental problem. You may escape the law. And for that, I would call you fugitive. Simple as that, isn't it? Simple as that. So clear your conscience. Know what you're doing. Now, what to do? What to do if you know today that you cannot comply? What to do? Let me tell you this. In this country, the law allow what is called best available technique, economically achievable. Do this. Begin from the raw mat, right up, scrutinize, audit your entire process. Khalid bercakap ni songkok terangkat ni makna marah lah ni. Okay. Audit trail your entire process. Find out, check all possible process improvement, including raw mat selection. Remember, hazardous waste minimization technique. Okay, so employ that. Now, once you have done that and you still find that your emission cannot comply to the law, inevitably, all right, you still cannot comply, then my next suggestion is apply for what is called contravention license to the authority. Apply from the DOE, contravention license. They will advise you, they will calculate how much you got to pay. Of course, some people call it a license to pollute. Never mind. At least you are given an advice. The most important thing is the advice of what to do. That license is not forever. The contravention license to pollute the air is not forever. It is periodic. It is given for a certain set of time, certain set of duration, probably a year, 2 or 3, depending on the authority. Now, within that time, what we are supposed to do is to look for improvement techniques to ensure our releases eventually comply to the emission standard. Now, this is talking about the legal. And where does the law? This is the law, Regulation 14. It is talking about dilution is not allowed. And the emission standard is in Regulation 13, third schedule, fourth schedule, fifth schedule, and also, yes, second schedule. Got it? So, I hope there's a lot of argument I read in my WhatsApp and email talking about diluting of pollutants before releasing into the atmosphere. There's a lot of argument. Some of it is a bit outrageous the way I see it. So I don't reply to most of this WhatsApp and email. So I kept quiet until I produced this video where I can express myself, not totally, but what I could think of at the moment. There are many other things in my conscience which I can't say literally right now. It just doesn't come. So I flow with this, what I say flow with this topic. And the intention of me producing this video is for you to share, to ensure that people do not dilute stat emissions Clear the conscience. Do not be scared of the law. Clear your conscience first. You feel it here first. The law is a guide, but we must know that we are polluting the environment. And we must know that we have a responsibility. The law is just a guide, so clear your conscience. You and me. I'm talking to myself as well, my wife and my family. And as human beings, we, in one form, in one manner or another, we are all polluting the environment. So in this case, air pollutants. So involving industries, involving individual, if you ask me. Now, this is what we are here for. So I hope you have a clear view that the law doesn't allow dilution. All right, and methodology of dilution according to the law, look, adding oxygen and even other gases. These are all high tech. For me, this is very simple. The diagram that I've showed before you is very simple. It's about mixing with ambient air. All right, so, and sometimes dilution can come from steam from boilers, cool down, steam from boilers or other sources to bring down the stack emission. These are all dilution, and it is not allowed by the law. Think for yourself. The impurities are still emitted to the environment. The environment is still receiving the loads of air pollutants. Are you okay with that? Are you okay with continuously contributing to the load of impurities in the atmosphere? Think, and feel it. All right. So that is about it for this session. I thank you for your attention. As I said earlier, I do not copyright any of my work. All right. You can produce and reproduce my work and teach people with this. I don't claim any ownership of this knowledge. And please do not forget to support my work. Be kind enough to subscribe to my channel and share it with your other colleagues, friends who might need to know this, all right? And even by doing that, is after you clear your conscience, you know what you do, okay? So for me, I know what I'm doing, all right? So it's your turn now. So thank you very much for the time and attention. I wish everyone safe from the global catastrophe now, COVID-19. I pray to God that all of you who have seen me in this video is blessed with good health, okay? And able to further live in this planet with a much more healthy environment. And hopefully we meet in one point or another, excuse me, and wish me in good health too, so that I could continue contributing this to the society. So all the best. Again, please share and subscribe, and and for this video, I end this with Assalamu alaikum wa rahmatullahi wa barakatuh. Bye bye. Take care.